Welcome everyone to the 32nd Data Science Seminar organized by the Institute of Computer Science at the University of Tartu. My name is Marlon Dumas. I am Professor of Information Systems and responsible for a number of teaching and research areas in this institute, including the field of business data analytics, to which today's seminar is related to. It will be my pleasure to act as a moderator to introduce the different speakers and their topics and to give you a little bit of context around that and the time to ask questions and interact with the speakers in the context of a panel that we'll have after the presentations. The goal of the data science seminar is to be a hub for disseminating knowledge about different relevant topics in data science within Estonia. And we have a tradition that the seminar involves both academic stakeholders and industry stakeholders, as we want to have more interactions in both directions. Today is no exception. We have two speakers from giving an academic or conceptual perspective into the topic. And we have two speakers coming from industry. Today, we are very glad to welcome Igor Artemtšuk and Jürgen Koitsalu from Swedbank. Today's topic is about business intelligence. So business intelligence is the exploitation or the use of data, typically coming from enterprise systems, but possibly beyond, in order to answer or address questions that are relevant for the optimization of business operations, for increasing revenue, for increasing profit margins, for serving customers, keeping them satisfied, and other relevant questions that make organizations sustainable. Business intelligence involves the collection of data from different systems and its storage in some system that from where a number of different other applications can connect in order to answer relevant questions for business stakeholders. We are going to talk today both about the what of business intelligence, what it is, when do you use it, how it works, and also about the why. What are the different use cases or business questions or business situations that business intelligence tools can help us to address. We are going to start with a presentation by Anastasija Nikiforova, who is our first speaker, and she will actually be talking about different types of technologies to support business intelligence, particularly data warehouses versus data lakes, and different use cases that these two types of technologies fulfill and how they can be used together in order to address a broad range of use cases in business intelligence. So without further ado, I let you proceed.
Second? No? Yeah, nice, great. Thanks a lot. It is my pleasure to be here, and thanks a lot for introducing me, Marlon. And indeed, I will speak about data lake versus data warehouses and data cleaning versus data wrangling and how to ensure the quality of your data. Actually, at the very beginning, it should be also stated that actually I will not propose a perfect solution. A silver bullet, unfortunately, doesn't exist. So I will bring just an insight on both data lakes, data warehouses, and if I will have sufficient time about data cleaning and data wrangling, why I refer to the term if I will have time, because actually my point today was to shorten the presentation, and when I started to do it, I came up with 2 more pages. So we will see how I will proceed, but I will try to be in time. So I will skip several not so very interesting details as regards myself and as regards some projects I dealt or deal with, although the last line could be of interest for our for our guests and collaborators from Swedbank. So actually, if you're interested in integrating artificial intelligence technologies into customer service, or just to know how it could contribute and to what you are dealing with, actually we could discuss this as well. Although primarily I am dealing with data quality management, and therefore will not waste your time and will turn to this topic. So basically my speech will be mostly devoted to one study I was pleased and glad to take part in the last spring. And we already presented a conference paper in a Eurocrease conference, and where I'm putting a note on Eurocrease because actually data wrangling and data lake combination to ensure the quality of the data we are dealing with was put in the context of CREASE systems, namely current research information systems. It is also called research information management systems, or RIMS, and etc. So basically at the very beginning we were focusing on the needs of research information systems, and therefore it is not purely the same, but I will try to put it in the context of which is closer to our today's seminar. So today it is not a secret that we are dealing with billions of data sources which continuously generate, collect, and exchange with enormous amounts of the data, which are not only huge in their volume, but also very different. So not only volume, but also variety are increasing. And of course, there is a need to integrate ever-increasing volumes of data, regardless of the source, format, or amount of this data, where data quality, flexibility, and scalability in connecting and processing different data sources are crucial. So we want to have an effective mechanism which could allow us to ensure faster value creation from this data. And of course, value is very closely linked to the term data quality. One might ask data quality, again, still, but unfortunately, or fortunately, indeed it is a case. It was a case 60 years ago where when the first studies devoted to data quality appeared, and when it was studied by mathematicians from the very theoretical side, and it is still an ongoing issue. Of course, the context changes, the types of the data we are dealing with, the technologies we can employ, and etc. changes, but nevertheless, data quality is an ongoing challenge, and it will remain to be as such. Because data and data quality, respectively, is a core for everything. It is a core for information we are dealing with. It is also the core for decisions we are making. And of course, it is also the core for business outcomes. And therefore, here I put the very well-known DIKY pyramid, which is a bit focused on financial or business domain. So basically business outcomes, which is related to wisdom, is very close to business intelligence. So in order to have business outcomes, and in order to be able to deal with these data and information and decisions, we have to ensure data quality at a very low level. So among other things, what should be taken into account that data quality is so challenging because it is use case dependent and very dynamic, as well as relative in its nature. And although it sounds very simple, but this is a core for this problem, why data quality issue cannot be resolved forever. And it is even more so considering the so-called absolute data quality, so a level of data quality at which the data would satisfy all possible use cases is not possible. It doesn't mean that we do not need to care of data quality, because the our data will not be of absolute quality, like never, but it is a fact to take into account, but of course to do everything what we can do in order to achieve as high level of the quality as possible. And one of the approaches how to deal with it is to take a look on our data repositories, especially when we speak about business intelligence and similar artifacts. So when we speak about data repositories, the first, and actually for very many audiences, the only option which comes in the mind is data warehouse. I assume that those people who come from Swedbank, of course, think not only about data warehouse, but also about data lakes. But maybe there is even something more. And considering that I do not know your background, and maybe you are not the person who deals with these concepts on the very daily basis, let me provide the overview of these both concepts and try to understand how to distinguish between them. So to put it very, very simply, data warehouse deals with processing of the data and organization in a single schema before being put into the data warehouse. This means that the analysis on this data is done only after this data was already prepared and stored in the data warehouse. As opposite, data lake stores the raw and unstructured data, which goes straightforward to a data lake, and then only when we need this data, we put it on and we deal with this. This is just to put it very simply. To put it even more simpler, data warehouse is about schema on write and data lake about schema on read. So here it is not a correct option, and what I just pronounced, so the opposite sides, will be the correct one. Even more, data lake is also related to so-called concept of single source of truth. Those people who come from the business intelligence area could also, right now, have a bulb in the mind that actually this is also what is stated about business intelligence. And therefore, these two concepts, business intelligence and data lakes, are considered to be together, and it is an ongoing debate, discussion how to put them efficiently together, so whether it is possible. So all in all, just to close this differentiation between these two types of data repositories, namely data lake and data warehouse. Data lake is about raw, large, and undefined data, while data warehouse is about refined, smaller, and relational data. So actually, we already can imagine what could be pros and cons of every data repository. Because data lake is about large and undefined data, and it gives us some sort of the freedom what to do and how to do and what data to have, because we are not put in the scope that we have to deal with mostly structured data, because although it is possible to deal with semi-structured data within data warehouses, but it is considered to be something exotic, and exotic not in a very good sense. But at the very same time, we are dealing with raw data, and actually there is a risk to come to so-called data swamp instead of data lake, because it sounds like garbage in, garbage out. But we will see, and actually there are some options how to deal with this and how to ensure that we are not dealing with data swamp, but we have a very good, very well-maintained data lake. Whether very good or not very good, of course, the practice will demonstrate. And as regards data warehouse, at the very same time, we deal with smaller and only relational data, but at the very same time, it is all about refined data. So it is some sort of ensuring that at least some quality is in place. Although it is typically considered that this data is absolutely qualitative because we have ETL processes compared to data lake where we have ELT processes. So just to remind you, ETL processes is about extract, transform, load processes. So transformation is taking place before we are loading this data, but at the very same time, it is not the same. So transformation of this data is not the same as ensuring the data quality. But nevertheless, it is at least something compared to very traditional concept of data lakes. So all in all, what you could also notice in this visualization that if we speak about data lakes, it is about unstructured data. So data lakes, of course, can deal with both structured, semi-structured, and structured data, but here we speak about how this data is stored in the data repository. In this particular case, it is unstructured data, where typical audience who deals with data lakes at the very beginning was mainly data scientists. It is not the case right now because data lakes evolved, and actually it is already the case that they are very, very well suited for business analysts as well. But at the very beginning, only data scientists. So if you want to have AI, machine learning applications, and etc., you go for a data lake. But at the very same time, we speak about data warehouse, we speak about structured data, both in terms of how it is coming to our data warehouse and how we are storing this data. For the users, the main target audience is business analysts. And here, yeah, it should be mentioned that while data lakes evolved, that they are considered to be equally good for both for data scientists and business analysts. For data warehouses, business analysts are still business analysts, and they are still the core audience. And for the use cases, we can see that actually they were intended for reporting and for business intelligence. So if we already see that business intelligence is listed here, why should we think about something better? And maybe it is a silver bullet. Unfortunately, it is not, and actually data lake is considered to be dealing with some issues that the data warehouses had. Just a small spoiler and teaser, they are not able to do so, but the next generation. So basically, data lake is considered to be the second generation of data warehouses, and the upcoming third generation, which I would say that it is pretty immature, so it is a kind of generation that. So it is about digital natives who really have everything, but they are not capable to deal with all those technologies they have from the very beginning. So this is a reference for generations in humanity. But at the very same time, data lakes, which came in 2011, actually started to deal with business intelligence. I will not go into detail about the architecture here because it is how data lakes look like at the very beginning, and I will have a visualization on how they look like today. So we will skip this, and as it was mentioned before, so yeah, we should be, when we go to data lakes, we should be really carefully how not to allow to turn our data lake into a data swamp. In a very few terms, metadata and governance. So it is just to put it very simply. Of course, it is not so very simply because otherwise it would be a silver bullet, but it is not. But otherwise, if we do not have in place data governance, so at the very beginning, the initial definition of data lakes doesn't stand that we will need to deal with data governance and with metadata. It is something lying under this definition. But at the very same time, if we do not do it, it is better to remain with data warehouse and all those limitations of data warehouses. But all in all, so if data lakes can bring some benefits and also in the area of business intelligence, so how to get these benefits? One of the options is just to have just a very great data engineers, which will allow you to survive in this data lake. It is one of the options, because another option, actually, it already sounded from me, so it is related to data governance. It is another option. Which one is better? It depends on your organization, on how many people are involved, so about actors, about data sources, about what you want from this data lake, and etc. And yes, here we come to the new concept, which I pre-announced as the third generation of data warehouse, and it is data lakehouse. Here, unfortunately, although we have some very more or less considerable, could consider that we have some strong definitions. Unfortunately, they are very different. So I will bring on the table several definitions of data lakehouse. Not so very definitions, but rather how they look like. So here we are coming at the very beginning to the visualization we had before when we had data warehouse and data lake. And here data lake differs slightly from what we had there. So what data lake developers brought on the table at the very beginning, they understood themselves that actually it is not a perfect solution, and they have to do somehow from it. Actually, we have very many things to speak about here, but unfortunately I will not have sufficient time to do this. Therefore, just to mention several disadvantages associated with data lake. When we speak about data lake, we most likely want to forget about data warehouses. But as you can see from the architecture presented here, data lake is supposed to have data warehouse inside the data lake. So on the one hand, it could be considered as something annoying, because why should I have two of them? But at the very same time, considering that data lake itself is not a silver bullet, and if we have a structured data and we have very clear understanding on what to do with this data, so only business intelligence and reports, and we know how they should look like, and we know that they will remain static for the whole time, and there will not be a lot of data incoming on a very daily basis, so just from time to time, it is better to remain within data warehouse. If we have a lot of data, including semi-structured and non-structured data, and even structured data, but we are not so very sure right now what we will want to do with this data tomorrow or the day after tomorrow. So when this purpose of the usage of the data is not clear, actually data lake seems to be the right solution. Thus, in this case, it is a kind of not one or another, but rather to put them together. And data lake is here to do so. Because as we can see here, for the purposes of data science and machine learning, so basically to explore the data and to deal with the data, but actually in the context of data lake, it is considered to be just to explore data, just to touch and to see whether it will be possible to take some insights from there, etc. So it is a very nice option. If we have a predefined purpose, such as reports generate on a daily or on a monthly basis or something like that, we are going another way. And data lakehouse is something what, as I just referred to the study I had together with my colleagues, is something we wanted to go to. And actually, this is nothing so very complicated from the very beginning. So we just put into between data lake and our output we want to have, we put metadata and governance layer. For us, as researchers, it was not sufficient, so we also brought here data wrangling, because metadata and governance, of course, they will bring something, but they will not resolve all the issues. So here we can see that actually in practice and in the market there are a lot of different tools, and they're also kind of not very sure which paradigm to use, whether to go to data lake, to data lakehouse, to data lake at the very beginning, how it was treated, and it was something closer to current data lakehouse and etc. So it varies, it really varies, and unfortunately both of them have some disadvantages and some advantages, and therefore we have to deal with this somehow. Even more in the context of the need of business intelligence, Capgemini Institute, I'm sorry for my mispronunciation if any, even brought up the concept of business data lake. Unfortunately, I'm not very familiar with this concept, therefore this is just how it looks like, so we can see that it is one more another architecture, and I will not go into detail, so it is just for your knowledge. In the case you feel that it could be of interest for you, you will refer to this, but I'm not sufficiently knowledgeable in this particular solution. So, and now just in a few words as regards our proposed solution. So because at the very beginning we spoke about data warehouses, data lakes, data lakehouses, and also some variations. And we decided to go to that direction related to data lakehouse, but at the very beginning to bring something more, so to put data wrangling. Because actually we want to avoid so-called GIGA, so garbage in, garbage out. And how to do it? We suppose that it is not sufficient just to have governance, data governance and metadata, because it will not resolve all the issues, especially considering that actually it is also not only about how to put it, how to develop it, how to invent it, and how to maintain, but also about the whole culture, whether all employees will be ready to do it as it was supposed to be. So here, when we speak about additional actions to be taken, actually in the vast majority of cases, what comes in mind of people we were talking about this topic is data cleaning. But as I mentioned for several times, we decided to go data wrangling. So let us put on the table both concepts, and we'll try to distinguish what is the difference, because data cleaning is everywhere. As regards data wrangling, it depends on your experience and your knowledge and etc. and have you faced them familiar or not. But in very many cases, people are not aware of the existence of data wrangling. So again, to put it very simply, data cleaning is a process of detecting and removing corrupted or inaccurate records from record set, table, or database. So it is a kind of a bit more of relational databases, although not only, but the very classical definition states so. If we speak about data wrangling, actually it is a subset of data cleaning because it includes data cleaning, but it is something more. And even more, it is not only about relational data. Okay, I just said that data cleaning is also not only about data cleaning, about dealing with relational data, but nevertheless. So data wrangling itself is a process of transforming and mapping data from one raw data form into another form with the intent of making it more appropriate and valuable for various tasks. So actually, it is much more than it is. Yeah. And here you can see the different subsequent steps that are included into data wrangling, and just to list them: discovering, structuring, cleaning, enriching, validating, and publishing. So actually you can see that instead of one data cleaning, we have 6 steps, 5 more steps dealing with data quality and hopefully ensure this. So we just put it together in the context of current research information systems and data lake plus data wrangling to data quality in information systems. And we suppose, we are on the infant stage of the study, that it will bring some result. Of course, we understand that it is rather an asset, not a silver bullet, but let's see. So in considering that my time is going to the end, yeah, let us skip everything else, and thank you for your attention.
Well, maybe that leaves time for questions, actually. Thank you very much. I said you should finish, but not too quick. But a good thing is that we have time to take 1 or 2 questions. If not, everybody understood what is a lake house. No, somebody didn't. Please go ahead.
So what do you think about fixing the kind of data in the source? So the data comes from somewhere. Why not fix the data in the source, collect better data instead of kind of pushing unstructured bad data into a warehouse or lake and then wrangling it, cleaning it? Why not fix the problem at the source? What are your thoughts about that?
Yes, it is a very good point indeed. And actually, when I referred to one of the first slides, actually, this is the point I am dealing with. So how to ensure this at the very beginning to be qualitative, not fixing it at the very late stage when we already submitted something to the external actor or something like that. But unfortunately, considering the data quality, absolute data quality cannot exist actually still, even if we have the data of sufficient quality in our data sources. When it will come in the data warehouse, most probably we will be able to find additional data quality issues because the practice demonstrates that it is so. And actually, if we speak about data lakes, for instance, considering that they are for unstructured data, including streaming data, IoT data, sensor data, and etc., not in all cases we will be able to fix this at the very beginning. So basically, still some noises and etc. in the data of that type definitely will be. As regards your point, indeed, there are very many debates and discussions right now. So why should we care about even the data quality within database? So when it already came, if we can really make at least some attempts to ensure that the data we are collecting and putting in the database is of sufficient quality. But unfortunately, data quality is a topic which will be relevant for very many years because it will not be possible to really resolve all data quality issues, all possible data quality issues at even the 21st stage, not even for the first one. But of course, we have to start with, so to minimize, to reduce the number of data quality issues to be dealt later on.
We have time for 1 more question, perhaps. Otherwise, you have a second chance of asking questions to Anastasija or to any other of the other speakers at 7 p.m. During the forum. Thank you very much, Anastasija, for your talk. So you might be wondering why these chairs are here. So it's going to be known as we progress. But one of the reasons is so that I can use them to illustrate what the different speakers will be talking about. So this is a data lake, or perhaps a data warehouse, yeah, or a lake house I heard today. So it is the recipient of all this data that we're going to be putting in order to perform business intelligence. And Anastasija's talk was mainly about this recipient. And she also started talking about the hose that we're going to use to put water on the data lake or the lake house, the different ETL pipelines or ELT pipelines that you will use to put water in there. Now, it is very important that the water that goes into this lake is of good quality. And what does it mean, good quality, right? As Anastasija was hinting, data quality is contextual. It depends on what are you going to do with it. The same data sitting in your transactional system, can have some missing values because they have not been entered. That's not a data quality issue when you are there. When you bring it into a data warehouse for the purpose of doing certain types of analysis, those missing values in the data can be garbage for certain types of analysis that you're going to do, and we do need to do missing value imputation and stuff like that, right? So we need to have very clear definition of what does it mean to put clean water into one of these data lakes or data warehouses or lake houses. And Mohamad Gharib, also assistant professor in our institute, has conducted quite a few studies lately on what are the typical requirements for data quality that you get in practice? And he's going to talk about that. In essence, he's going to define what clean water means. Please go ahead.
Thank you very much, Marlon. Thank you very much for inviting me. So as Marlon described, I will be speaking about what constitutes data quality, because basically this is what we'll be speaking about now, and the requirements for this data quality. So we can skip to save the time. We saw something like this before, more colorful, but still serve the purpose, and I don't have the wisdom above the knowledge. But in general, there was a lot of dispute about defining these three terms before, but now more or less they stop arguing about them, and they have clear, more or less, definition of them. So the first, define the data, which can be defined as any raw entity. It should not have a meaning. When it has a meaning, you put it in context, it became information, and when you aggregate this information in some sort of context, along with the, more or less, the rules to infer new information or even knowledge, it can be called the knowledge. So it's very easy to note from this simple diagram that if I have problem in the data, it will propagate to the information, and it will again to propagate to the knowledge, which basically I will be using to make any informed decision. So bad data will result in bad information, which in turn will result in bad knowledge. So there is a lot of studies related to the cost of low data quality. It's very, very, very simple to find. There is so many, let's say, disasters usually happen, but usually these are detected after the disaster happened. And it's usually when you do the analysis, the reports, you understand there was a problem, mainly can be related back to the data quality. So you have an issue in the data quality, you will have an issue in the design, you will have an issue in the system when it's put in its operation environment. And these are just simple examples about disasters happened due to data quality, or may happen because the F-35 is not operational yet. So basically, also this is quite famous taxonomy related to the cost you might encounter, but usually taxonomies give you more or less just an idea to understand what results or what consequences you may have. They are general purpose, and we will see later why general purpose stuff are not really good in the context of data quality because it's highly domain dependent. So in short, as we saw before, everybody or almost all organizations, any complex system will need the data. And data is described as the new gold. It's fueling almost everything. And many companies are using this data to derive the decision they are taking. And we already said that low quality, low decision. Just to understand the importance of having high quality data, now if your company does not have the resources to provide you with high quality data, you can go to a new business called data broker. Not really new, but became very famous lately, not related to data quality, to privacy, but still. And you can just, looking at the figures at the expand in this area, you can understand how important it is to have high quality data. It's not an option to most companies to stay in the business. You need this data, you have to dedicate resources, you're not able to, you have to go to data broker and buy it, just to understand how you can conduct your business. So basically, everybody needs high quality data. We know low quality data will result in disasters. If we took the general definition of data or information quality, it's exactly the same as the definition of quality. And basically, it's fitness for use. Very, very broad definition, but agreed upon. Everybody will define quality, data quality, information quality as fitness for use. If we took just a small look on the small diagram, this is just partial, but basically data is used in almost any domain we are working in now. All of them want high quality data. None of them will be willing to depend on low quality data just to make an informed decision. A decision that they believe will more or less give them advantages in the market, saving their system from failure. Sometimes failure can be very, very costly. But if we also look inside any of these domains, or also inside this domain, the system, different system in these domains, it will be very, very, very hard to have more or less general view of what high quality data is. To solve this problem, this is a very active area from a long time ago. There is general agreement in the area that's data quality, same as information quality. It's more or less an umbrella concept. An umbrella concept you can analyze through dimensions. Things more refined, I'm able to analyze and say whether this data is high or low based on these dimensions. Of course, this is a subset. In some studies, they identify 193 dimensions to the data quality. Some of them are repeated, some of them have very close meaning, but this is still a very small subset of the concepts related to data quality. So basically, if I depend on this model, everything will be fine? Actually, no, because also if you check the literature, you will find so many models. And there is more or less problems in these models. The first problem, they are inconsistent with the dimensions they consider. If you check the one on the left and the one on the right, they are not the same. Both of them are used in some sort of systems, but they are not the same. The other problems, you have also the interrelationship. So basically, I have a concept, I have subdimension of it I can analyze, and this subdimension may have subdimension. But basically, if you compare some of the available models, you will find a lot of inconsistencies among these subdimensions. This is a problem? Yes, it is a problem, but the bigger problem is if you check how they are defining these dimensions, which will be used to analyze the data quality concept, you find also, again, problems in the definition and how they are analyzed. So this is a problem? Usually, yes. Because if I consider all these problems in the available models, I will not be able to have a model that fits all. And this is basically not really a problem because data quality is context dependent. It will depend on the domain and the system will be applying this data. So basically we have so many diversities because simply one size doesn't fit all. So beside the problems of the model, if we went to go to the level of the dimensions, and we mentioned only few, we need to understand how they are analyzed. Sorry. So this is a very simple example. We have up reference data, and we have down the same data. More or less, it's represented as a row in a database, familiar to everybody in computer science. If I want to understand, or more or less take example of the, let's say, most important dimensions of data quality, here we have the accuracy. And basically, according to its definition, it's very easy to understand here what's the problem. I have the reference data up and the data derived down, and it's clear that I have problem with the accuracy of the ID cell. Again, completeness. I compare again, and also it's very easy for me to understand which data are missing here. So the last one, timelines. Usually called also validity, one of the problems, having different names to the same dimension. And basically, I just need to understand the change rate, the volatility of the value and the reference data I have and compare it with the other data. And I will be able to say if this piece of data is valid or not. So everything is simple. Why everybody is still losing money and everybody is complaining the data quality level? Because here we have two assumptions. Probably I should have said before, but it will not be, the problem will not be clear. The first problem, the main problem in any of these definitions are more or less are relative. So if we check the first one, the accuracy, you always need a reference data to say my data is accurate with reference to this data, which I consider it as the single source of truth. The other problem, if you check the definition of the completeness, basically I can analyze it only based on its completeness for the purpose at hand or the task I want to perform, and this is a relative definition. So if I'm not really sure about the task I will be doing, it's really hard to understand what kind of data I have to add to take the right decision. The final one, you see timelines. It should be sufficiently valid, and this is always also relative. highly related to the system I want to more or less analyze the validity of the data for. Anyway, the big problem is not here. The big problem, all of these are within an information system where I know the structure of the data, I know the content of the data, and more or less I can refer to it to more or less do some sort of analysis to say if my data is good or not. But this is not the case in real world. Because basically, in real world, your data is not in the information system. Your data is up in the wild, in the real world. And there is a lot of work just to map the real world into the information system in order to understand what's happening and in order to understand which is our reference data. This is a simple diagram which basically classify. This is partial, just to simplify the representation. Everything in the world is a thing. Each thing has a state. The state can have set of state variables which has a value. The state can be changed depending on event that's subject or governed by law. On the other side, when I want to map this to my information system, I have something called information object, which basically should represent the thing. And I have something called data item, which has the value. And basically, I will be trying to compare this value with the value of the state variable. Very nice as a picture. Now, more or less, we understand the problem. So it's not within the information system. The information is coming from the real world, and I have the reference data. Here I have another problem, moving the value from the real world to my information system. And I can depend on so many things to do that. Basically, things as simple as sensors, you can use cameras, or even you can use humans. Each one of these means have its advantages and problems. And the most problematic one is the human. Unlike sensors, humans are intentional entities, and basically, they are not usually very reliable to depend on. And if you remember the figure at the beginning when we spoke about the knowledge, a main problem in humans, they do not work as sensors. They have internal knowledge. And basically, they do not see the real world. They interpret the real world. That's why when we use humans to more or less make this transition of the value from the real world to the data system, we have a lot of problems. Another thing, humans per se, they can work as information system. They can create information that doesn't exist in the real world. And here we will have very big problem to identify the reference value, which we will compare our data with. But anyway, regardless of all these problems, based on this simple diagram, I can analyze only the three different dimensions I was speaking on. The value of the data item can be compared with the state variable on the left. Very nice. Any changes that can result from state should be captured with the function in my system, but I need to understand the law governing this change, but still can be doable. It's a bit more complex about the completeness because I need to understand the system I will be working on. But in general, it's doable. So basically now we have more or less something enable us to map the real world into the information system. There was the term requirements at the beginning of the slides or beginning of this talk, which we didn't speak about until now, simply because requirement engineering is fundamental area, and it will be the easiest here. In general, not only data requirement or information requirement. In the requirement engineering, usually they specify the requirements for the system to be built. So here we are speaking about something before implementing the system. And we need to understand both the functional and non-functional requirement of the system. This is the general things that the system should take into account while you're designing it. The main difference between the two, the functional requirements define the more or less functionality, and they have this kind of requirements, have very, very clear cut for satisfaction, and it's very easy to derive the formal specification which will be implemented. The non-functional requirement, usually they are quality requirement and they are very hard to deal with. So you are not automatically able to derive the formal specification. Data quality requirement is some sort of quality requirement which is non-functional requirement, and again, you cannot do the transition from the requirement to the formal specification directly. However, there is some sort of approaches you can use to do this transition, and instead of getting informal specification, you get formal specification. But in order to do that, you have to do the analysis we did before, or we spoke about before, which we didn't do. Basically, you have to define the data model for your system, and this requires a lot of investigation, the domain of the system, and also the system to be implemented. Then, after a while, you more or less, you will get some sort of data model you can use to refine this kind of requirements. After that, for each dimension you consider, you should define something called quality space, how I can measure this in order to transform this kind of quality requirement into formal specification. And at this stage, more or less, when everything is clear for you, you can start from something not clear, providing the measures, providing the way you will try to more or less refine these requirements until you reach the point you are able to give them to somebody and tell them this is the formal specification that the system should more or less implement. So I don't think we have a lot of time, but this is a very simple example. Some problem, we spoke about it before. And basically, this is a very famous crash in the stock market, happened in 2010, lasted only 36 minutes, and resulted in the loss of $1 trillion in the market value. First of all, this kind of system are quite resilient. They are designed, after all, they deal with money, so they are resilient to any kind of problems. Different kind of problems, more or less, manifested themselves in the system design. This kind of system, this is a huge system. It's called system of system, and they have some sort of emergent behavior, things you don't expect they may happen, but sometimes they happen. Anyway, when you have this kind of, let's say, crash, a lot of reports, investigations start to occur until they understand what happened in order to prevent it from the future problems. Many of the problems which contributed to this crash, first of all, this is enormous system, so they don't have a single point of failure, so anything can contribute but do not lead directly to the crash of the system. Many of these things that contributed to the crash were related to information or data quality, as we call them today. In order to understand how I better need to design this system, I need to create first the data model, and I'm almost done. And basically, this was the data model we built based on the problem at hand. I will speak about only 2 dimensions which we needed to analyze. The first one was related to the accuracy of the data. Some, let's say, some traders, they are called high-frequency traders, use their capability of trading in very, very, very fast pace to manipulate the system. This kind of behavior was coupled with other related problems and contributed to the problem. So one of the problems was understanding how accurate the information they are providing is. And this is one of the problems that you don't have reference data. You cannot say this is accurate or not because it doesn't exist in the real world. It's built internally for the agent. And we more or less analyze the accuracy based on the dimensions you see. There's much more than this, but just to keep it simple. The other problem was related to the completeness of data. As I said before, this system of system, most of the systems are expected to work together, but not as single integrated system. Usually in trading venue, when some problem happens, they have some sort of mechanism called circuit breakers, some sort of fail-safe mechanism, very famous in safety engineering. They just stop the system from working. And in the case or in this crash, one of the venue closed, applied their circuit breakers, other did not. And when you have only one venue working, all the quotas will be going there and the problem will continue. So you're not able to stop it. This is just simple examples how the quality of the data can be important for the system to work properly or as it's expected. Thank you.
Thank you very much. Maybe time for one little question. No, everybody understood that one question means less time for the coffee break? Oh, yes, go ahead. One question. We'll still have the same coffee break, don't worry.
So I would like to ask, at what point would you say this data quality requirement should be figured out? Because I worked as a requirements engineer, and usually you don't go in too much deep in beforehand if you're building an information system. So,
Yeah.
And trying to figure out data quality requirements, like you said yourself, you need to have clear understanding of data model, and you need to have clear understanding, but that usually becomes in the work if you take an agile approach. So when would you say you analyze data quality requirements?
When you find the point that you have more or less understanding how it will be implemented, but you don't go into implementation details. I have this solution. I know, depending on the current technology, it can be realized, can be implemented, and you stop back then. So you don't define how it's implemented. You reach a point when the specification is clear, and that's it. But this is not only for this, for all kinds of requirements. So you reach the specification, the points that everything is clear, we stop here, we give it to the implementation.
We do have time for one more question, actually. No. Question 1, question 2, question 3, gone. No question. Great. So we're going to now have like a sort of 10 to 12 minutes type of break. And we're going to come back to see a little bit another perspective into the topic, more from the perspective of use cases, business benefits, and organizational and governance issues, and the technical part of, like hands-on insights into how what technological and technical challenges pop up when you try to implement BI in a large organization like Swedbank. So 12 minutes break, and see you. We'll restart at 10 minutes past 6. Thank you. Okay, so I already explained you why these chairs are here, right? So this chair, it's the data lake where you're gonna put the water, which is your data. And we heard that there are different types of lakes: lake houses, data lakes, data warehouses, all sorts of things. And there are hoses, which are extract, transform, load, or extract, load, transform pipelines coming from different systems that put water. Sometimes it's a little bit dirty, sometimes a little bit clean. So sometimes you even need two of them. That's why there are multiple chairs here. So there is one where you put the dirty water first, or kind of, and then you define how you want to clean it. And then there's another one where you put like cleaner water, and then people can drink clean water from it. And the question you have is like, when you put clean water, it depends on your requirements, as we heard before. And so it depends on the use case, it depends on what people will do. People will drink. That's why there are four of these things here, is because there are going to be different people, which are going to be business owners, who are going to drink from this clean water in order to get insights, to answer business questions, to produce value for the organization, because that's the ultimate goal of business intelligence. So that's the first thing we're going to hear here now. We have from Swedbank, Jürgen Koitsalu, who is Chief Product Owner for Business Intelligence. Interestingly, Swedbank treats business intelligence as an internal product that different stakeholders are consuming. So this is the product, and then there are different stakeholders in the organization. For example, the head of consumer lending, who are consuming that in terms of getting insights to how to improve the customer experience when you ask for a loan at Swedbank. Not that I am advertising in any way Swedbank here. Actually, initially, when I was hired at University of Tartu, I was the Swedbank professor of software engineering, so I owe some advertisement. So then, over time, what happens? and that's going to be Igor Artemtšuk talking to us about, and that's why there are 5 shares, is that in a large organization like Swedbank, they bought 2 of those things, of those shares, and turned them into lakehouse or data lake and data warehouse, but some data cannot leave the company, so they had to have an on-prem data warehouse and another on-prem data warehouse. I don't need to move all the shares for that. It's going to be a nightmare to put them back, but you can imagine all those shares lying here. And then it becomes a governance and a technical nightmare, because sometimes you need data there, you need data from there, you need data from there, but this data is dirty and you need to move it there where it's clean. And there are all sorts of I hope there's nobody from that department like hyenas, so that are looking for reasons, to bite you because of some GDPR issues and stuff like that. They are called data governance or data security people, and they are looking for, roaming around to see if there is a lion who is like, drinking water and the water has some GDPR contamination and biting you from the back, so those are the data security people. I hope there are nobody from information security department. And if we could remove this from the recording, please, that would be great. So that I do not get blamed by them. One day I might need a favor from them. Of course, that was because you're going to listen to a 40-minute presentation, and it's going to be a little bit long. To compensate for that, Jürgen is going to use orange slides to keep you awake. Your turn.
So, hi everyone, I'm Jürgen. So I'm not the chief product owner for all of GBI. GBI is a large institution in Swedbank. We're around 700 people. And I'm chief product owner, product manager for an area that brings data into our warehouses. Data lake is not yet under my control, but next year. So I have a set of teams who kind of deal with the information layer, and kind of just to give the context, that's the perspective that also a little bit drives my viewpoint. And I have Igor with me here, who is our group data warehouse head architect. So he will be the guy actually who talks the interesting things to you. I will do the business perspective. But to the lovely example about the chairs and about security people lurking around, we actually have them within our unit as well, not only like outside. And ours are quite nice. They make the problems visible, but they also help us solve it, not just they don't come and shove it down our throats. So we're very happy with them. But what I'll talk to you about today, or what we will actually talk to you about today, is, well, you've kind of gotten what is business intelligence, so I can skip some of the stuff a little bit, but provide the context, and also introduce some of the BI principles on how to make it happen. And it's connected actually quite a lot to the previous discussions. And then Igor will go a little bit deeper into warehousing, into lake perspective and things around that. So before I kind of jump into BI in general, I think we've all kind of understood already that we live in a data-driven society. That it means that we are willing to give out information about ourselves. So it will be used by service providers, by others. Of course, GDPR, and it will be legal and kind of proven use, not illegal use, but still so that we could get better products, we could get better governance, even from a country perspective, and that we don't expect that leadership only comes from gut feeling, but it also comes from facts. And so data is a major part of it. And the problem is, how do we interpret this data, and how do we make it information and everything around it? So that's where business intelligence comes in. But as we've already kind of talked about it a little bit, all I want to say is that business intelligence also is an umbrella term. So it's not just a philosophy, it's a set of tools, principles, the competencies, and everything brought together to enable the value of data itself. And I'm not going to stop any further here. So coming to examples that how how the bank, or in this case Swedbank, or probably other banks as well, or big corporations can use BI to our benefit and to our customers' benefit, because if the customers are happy, we are happy, shareholders are happy, everyone's happy, you know. So from that perspective, BI enables quite a lot. And if I want to roughly categorize it, I can kind of split this in two. So one is running the business, kind of making the money, let's call it, or kind of providing the products. And the other is the regulatory requirements behind it. And I'm going to start with the regulatory requirements. Those are the boring ones. Then we get to the better examples that because, you know, in this case, we are a bank, or also for big companies and others, there are a lot of regulations, rules that we have to abide to. We need to report our activities, show how we're doing. And it's not only to kind of monitor us or one company. In financial world, it's also to monitor the health of, for example, Eurozone or Europe in general. All the banks give this info to central banks, and based on that, they see how the economy is doing. So it's also metrics in that perspective. So in order to do it, there's financial reporting like FinRep. There's other, you know, kind of metrics and kind of levers that can be used. And this all happened before business intelligence. I wanted to kind of make this kind of comparison visible here, that all of this happened before business intelligence as a concept probably even existed. But what happened was that a regulator told the bank that now you have 2 years to figure out, you know, how to interpret our rules. And then you have another 2 years to provide this information to us. And so we have 4 years to send out one report. You know, it probably wasn't even Excel yet. Maybe that wasn't invented by then. So one Excel row, some columns, 4 years. The world we live in today is that, of course, we still have yearly reports. They're big. We have monthly reports. In the Baltics, we have daily to FSA. We have daily monitoring for anti-money laundering. If something is wrong with that, we have 2 days to notify the authorities that we're not able to monitor the flows. So the world has changed around us, and that's why BI becomes even more important. And everything that's been discussed here, how to enable it through the lake, to the lake house, what's the context to understand that our data is qualitative, with quality, and kind of it all merges together. So I'm going to give you some examples on this slide about the use cases that we have, and what BI enables from a business perspective. So I mentioned FinRep, that's purely regulatory. But there's also credit risk reporting, there's market risk, there's also these things that we do for ourselves, and you can see risk management is actually in both of those things. So one interesting thing is that while we do this, we just don't report. We do a lot of this stuff to actually get grading or licenses, or banking license or something. And one excellent example is in credit risk that it's called IRB, and it's an internal ratings-based approach. And what it means is that we need to have our own, let's call it, self-assessment of our risk as a bank, of what portfolios and things we have. And when we do that, and when we do it like well, let's call it, then the regulators kind of accept it. They see that we have good risk control, that we understand who we are lending our money to or who is using our products, what risks we take, how do we mitigate them. And based on that, if we get the good scoring, we get to be in a situation where we don't have to have so much capital on hold to cover our loans. So we can have less capital on hold, which means we can actually have more free money to loan out again or to do it, you know, something else with it. So the whole purpose of a bank is to take instruments, money, things in, and then send them out again, and then get a commission in the middle, or to invest and grow it. So, and also to make it available for other people. And the less money we have to keep locked to cover our regulatory things, the more we can do it, the more we can supply this value. And so, actually, by doing regulatory stuff, so to speak, official term, regulatory stuff, then by that we enable business value and also value to our customers. So that's the boring part. But it's banking, so most of it is boring, but now it's the interesting banking part. So running the business also, that that it can be wall to wall. It can be information to management, how some graphs are moving. Is this number going up and down? What's our return on equity? And so someone on the board can make a decision like our direction will go here or there. Or it can also be customer management to understand what the people are doing. That how do they talk to us? What channels are they using? Do they call us? Do they visit us? Do they use the internet bank? How much? How much do we use the mobile bank? So we would know, where to develop our services and what products to offer. Are people using credit cards abroad? Some group of people that in some segment that we've already segmented, that's a totally different topic, is using credit cards abroad all the time, maybe offer them a credit card with travel insurance, for example, that this is what is enabled from some extent from the operational system if they want to do digging in their information, but they don't see the rest of the customer's behavior that comes from the other areas of the bank. And BI is kind of the tool that's bringing it together under one umbrella, so to speak, and cleansing the data, all the principles mentioned before, and kind of making it available to us. So you're seeing this picture for the third time today, and it still applies that to reiterate our goal, it's actually that we are here to gather the information from our organization, or it is sent to us, but by the rules that we help define and principles. But it has to be in strong collaboration with the people who create that data and who use that data so we understand the context, because otherwise it's just noise. It's a data swamp, as mentioned before. So while in doing that, we turn this into knowledge and wisdom. So there's like a streetcar example, but maybe to give you a banking example, card payments and regular payments. You probably do it all the time. As I mentioned with cards, to give you the kind of credit card with travel insurance, there are other ways as well that all of this card information is data. We add layers to it. What agreements are they tied to? Who's the customer? What other products they have? It starts becoming information, moving towards knowledge. And then based on that, you see what products you can offer. Or from another perspective, the same information from another angle, you see what the people are doing, how are they moving money. We have a customer who every month, first day goes and takes out 10,000 euros and does nothing else in the bank. Kind of suspicious. So that can also go into kind of making this data available, connecting it to the rest of the info, and then it's fed into the systems that build scenarios for anti-money laundering. And there will be red flags popping up. We see that some revenue streams are very suspicious, they need to be investigated and so on. So it starts with the same data, the same system sending us all the card transactions, all the clearings. It's the same data as long as it's with enough quality, but of course it comes with context. AML is interested in one thing, controlling and steering in another, but roughly we kind of reach it, and then we build this up. And through this, we can kind of do these use cases, but there are also cases where we can kind of, not just make money, so to speak, but to make life easier for our customers. So one example, which is a terrible example, which is the war this year, is that when we started getting an influx of refugees coming into Estonia, then probably some of you have felt what it takes to get a bank account first in Estonia, and the 200 euro deposit or something if you are a foreigner and have a permit, and I don't remember all the rules, but then a decision was made that for refugees, we will make this process easier, that they don't need to go through this, they get this very quickly. However, at the same point, there's a criminal element, not the refugees, but someone else who maybe wants to take advantage of it. So what we've done, can't go into all of the details, but when these shortcuts are taken, then this gets registered. We store this, we make it available for later analysis to catch if someone has abused this system. But at the same time, we don't make those people suffer any further. They get the account quicker, they get to come here, they get to live peacefully for a while. So from that perspective, that's what BI is enabling. It's enabling new insights. It's enabling kind of better products. It's enabling us to have more capital available to do more business, so to speak, to be more efficient. And also if other areas of the bank need to talk to each other, they don't need to build their own solutions over and over and over again and keep the spaghetti monster alive. It's coming through a funnel. However, if you start thinking about it, that means that we have a lot of data. As mentioned, lakes have petabytes. We're not there yet with our lake, but warehouses have terabytes. We have hundreds of those. So we're kind of in a situation that how do we keep this all together? And to do that, we need principles. We need to have it driven by business, not that it's just a department in a basement somewhere that says like, give me all your data. So it's driven by business, it's driven by the need, it's aligned with the strategy, and we are as a unit aligned with the needs of the bank, and everyone understands that. And that we have different competencies to support all of those initiatives. And one of the biggest ones is reusability. As I mentioned in the previous example, that the same cards data, it's sourced once, but it's used in anti-money laundering, product offerings. It can be even used to do like next day analysis, that if your credit card paid something in Africa and then 10 minutes later in America and then in Brazil and so on, then probably someone's stealing your money and we can close it down and then notify you. Of course, 1 day lag there is a bit too much, so there are other tools to make it faster, but still BI can enable that if we're talking about warehousing, for example. And to keep it all together, this massive picture, what's really weird is that we have so much data that we're having trouble understanding what all of this data is, because there's just so much. I can't even remember, honestly. I could say like 100 different source systems, different areas, leasing, lending, factoring, just general channels, you name it, anything with banking, it kind of flows into us. But this is the weird part, that to understand all of it, we need to have more data. We need to have metadata. But that was also already mentioned in the first presentation, that metadata is something that's also necessary to kind of clean up a lake, the same way it's very instrumental in a warehouse. So I think that I will start kind of winding down, as I've taken already quite a lot of time, and we'll give time for Igor to start walking slowly up here in a slow-mo action movie way. And this is kind of the best kind of interpretation I could conjure up for Swedbank's current BI architecture. So you can see the data lake is present. It's maybe not utilized to the perfect idea that it should be, but we're kind of growing this competence. We have warehouses still. There are also legacies, but kind of this picture. And you can see on the left, there's also, 5 something items, but there's much, much more. We have information from General Ledger. General Ledger is like the Bible in banking. Like that's the book that says how the things are. So if something is incorrect in General Ledger, that's bad. If your numbers are incorrect against General Ledger, then your numbers are wrong. So General Ledger is the truth. And then, this kind of visualizes how all of the information flows in, and what we do in the middle, what's already been discussed by previous speakers as well. What I mentioned very briefly about information management, about data lineage, metadata, and you can see also test data management, everything about the previous presentation. It sits under here to enable all of it, and when it goes out, it will be handled by customer management, risk management, and all the other areas of the bank and steering the bank. So the few examples that I gave you. So that's the context about BI. But now, Igor, please, you're up.
Thank you. Is it working? Well, good, thank you. I will continue from this slide, actually like this one. So yes, we have several warehouses. There are old ones, new ones. That is the problem of enterprise solution, that it is becoming quite huge, and you cannot let's tomorrow switch to something else. So then it is a problem that we need to solve. And this data lake, I remember 5 years ago, it was the case that let's buy data lake. It was outside, it was all the word was let's buy data lake. It was all our problems. Well, it's not.
it's not solving by itself. You need to work with that. And actually, a lot of enterprises, a lot of companies are coming back to the warehouse concept, meaning that you still need to understand the data. You still need to do so. Then it comes to this different virtual warehouses, logical warehouses to combine with data lake. But for sure, this is something that should allow to deal with the real-time data, which is becoming more and more crucial and needed nowadays. If Jürgen was talking about the BI, what business needs there are, I would say that if from the perspective of technical, then what it means, it's actually automation of the process, so that it helps to give this time, so everything is possible to do manually. But with the automation, with this BI, you can do it much more faster. Quality, of course, you can do that, but again, a lot of the process, a lot of things, the quality is quite important here, and BI, automation, warehouses, data lakes help to solve that. And transparency, of course, for the data. Instead of one person going to one another third database, grabbing the data, and then something lost in the flow, and where is that coming from? That's the audit is coming and asking what's happening with that data, and where is that coming from? So this we need to solve. But if what we do, we provide BI services. So this is, say, this is some kind of service which includes this four concepts here. So collect the data, manipulate data, data discover, and provide data out. So as mentioned, we have, actually it's more than 100 sources that we have. We have different countries, we have different areas, they have own databases, they have own technologies, some providing files, some providing some kind of XMLs, whatever. So, and BI is very good at solving those problems and dealing with that question. Then manipulation with data. Let's say, don't consider manipulation that we create and add some values and I want to add to my account 5 more years. Manipulation means like aggregate data, to present it differently, to do it somehow, prepare the data, and also look for the process to deal with the data when it's ready. Data discovery, this is the part which helps to understand the data. Quite often, before you want to digest the data, you want to request the data from BI service, you need to understand what it is. And their discovery, this BI helps a lot to find, this provides different tool sets to dig into the data, to understand the data. And the last point, it is provide data out, so that we need, as a service, provide data out to our consumers. And what's important from the BI view, as we have different users, they are non-IT, IT customers, different tool sets, we need to provide it in the most useful way for the consumers, but that it is less painful to the BI with different performance or some other issues coming in. And our concept, as it was already mentioned, that do once, use many, like source one, use many, calculate something once, use many times, so that this is reusability is very important. That helps a lot to with timings, also with the data, that it is the same data for everybody and that you don't have this multiple times. This I will probably skip because I think that Anastasija already thought about data lake, so I will not go that much. But so let's go here probably. What's the data warehouse for us, and what this is? Do I have? Yes. So as it was mentioned, so data lake is generally for the data science and data analysis, but warehouse for business reporting and analysis. So this is where we have productionized flow. So what is really doing to the end users and consumers. And if you look for the warehousing, then what it's concepts which are important for the warehouse, it is data integration and consolidation. What it means, it is the pain. We need to do that, but when we do it once, and generally then it is helpful for everybody else who use the data further on. This is modeling data in some specific models or some specific subject areas, so that the different data coming from the different sources is understood similarly or stored in a similar way, meaning that, I don't know, maybe private customer and business customer, they have different attributes, but from the logical perspective, this is still customer. And store it at the same place, use it at the same place. Also, if you have contract, card contract, you have leasing something, you have mortgage something else, and you need to know that it is actually connected to one and the same person. Then this also should be able to be combined, because the idea of the BI is to create this reports to create insight. Again, this data should be described. Again, this context is very important to understand what data and to understand that is it the same data or not. I have probably, say, one metric regarding me, some, I don't know, maybe my income, regular income, and there is another modeler who wants also to use a regular income. Is that the same? Is it different? And the data should be described, it should be clear context, and then it should be clear that is it the same or not? Is the data here in this object is what you need or not? So this is really helpful to understand, to integrate the data and to use further on this data. Data should be validated, sure, the quality, as we heard, it is really important. It's question from, I don't know, all days, still valid, still continuous, still should be solved, and this is what the warehouse is dealing all the time and what we should solve. And the idea is that it should be, by the design, we should try to do this, that its quality is included into design and the process, so that you not do it afterwards when you have already something implemented. Let's look for the quality, but it should be at the beginning of the phase, so that you think from the beginning how you will be tracing the quality of the data. And then the data historization. This is a point which is very important for us, meaning that we're quite often dealing with operational systems. They have some kind of snapshot current situation. Maybe they have logs what was happening to somebody else. But from us, the reports are coming. They want to know maybe what was the balance at the last year or 1st of January or maybe 2nd of January or end of each month. So that then we need to have this date context, date dimension added to all the data so that we understand at what time of what period we are talking about. So this is one of the concepts we need to always to handle, and we sometimes need to add it to the systems that themselves do not have this historization concept as themselves. And this, as so mentioned, this data preparation for consumption. As said, we have different users, and we need to have data prepared in the most useful way to the consumer. So is it common for everybody? Is it specific to some areas? Is it some kind of denormalization, marks, whatever? So this is the point that decisions should be taken in the architecture, decisions should be taken in the solution. How we can solve, what service we will provide as an out. This is one example of this financial model, how the data is, can be modeled. I wouldn't say that this is ideal. I wouldn't say that this is only one, but this is one of those that market providing. So this financial services data model, meaning that there are some subject areas, some concepts that exist, and then when the new data comes in, it becomes the decision, okay, I'm getting data, each attribute, where to which box it belongs. Then you find the boxes, there are sub-elements there, you find the relation, how this should be connected. And there it comes the decisions like what it should be done, how we should proceed, and how we should model the data. This is, as you can see, so there's party, is describing some individual. There's agreement, which is describing the contracts, events, which is describing some kind of activities, products, whatever. So these models in general describe the financial activities, banking as itself. But of course, it's happening that sometimes there are new concepts appearing, or we want to add something which is not there, and it's already decision inside, like, should we do that? Should we fit into one of the boxes, or should we make one more here? But again, it is not that, for us, it's not the case that, okay, something new, let's new box, and again, new box, because then you can continue with that all the time. But we want to have some kind of stable system, so change it as less as possible. That was the logical structure, but if we come to the physical structure, there are concepts or the elements by which we select what should be the structure. One, it is based on the tools, meaning that, of course, some tools are really good to work with star systems or something else. Others are working well with normalized, denormalized structure. So it's one element you should consider what kind of tool set it is. Another point, it is the selection based on the use case. One is technical use case, so one it is data storage, how it is easiest to store the data, how it's easier to take data out, how it is the best to manipulate with that data. Another approach, not approach, say we should consider that what is business, or it's a user usage, meaning that how they will see the data. Do they understand this model? This is also quite often the case for us that consumers do not understand our model. They do not want to understand that. Then maybe some other structure would be more useful, maybe more understandable for them. And as a result, we're coming to combination of structures, which actually we have, which we need to do so that for different use cases, for different elements, we have one another structures inside. So this is one example here. So you can see this is third normal form, so normalized structure, and also the normalized element there. And I would say that most of our main model, it is normalized because it is meant to store the data to be used once as a central point. As you can see, so this is, for example, we have party, which is general information regarding customer. Then there is party reference, which is some kind of reference to the source information, where it's coming, what it is for, so they can always trace down where it's coming from. Party feature, describing different types of attributes related to that customer. Maybe party relation, so how the customers are related. Maybe it is your manager, maybe it is your son, daughter, whatever. So you can have these different relation types. Some elements, like for example here, party classification, party segment, theoretically they can be party feature, but as themselves being quite a big concept, they are taken out of this generalized feature to be the out and have their own word outside. It's not directly our structure, let's say, but this is quite similar to how we do the modeling. And of course, each of this element, and if you look, like zoom in, you see there is more out inside. So you can look for this financial model. So they have this different structure. What it helps, how it works, so that if the new data comes in, for example, I want to have new segmentation, I don't have to remodel it, because I just need to register some new attribute, and this fits into the model without doing some changes in the structure. So that this model is quite agile. You can fit in a lot of stuff inside. But on the other hand, there is party header. This is a derived object with the data, which is having here separately each attribute: start date, end date, last name, first name, something else. So segmentation, everything in one object. It is quite easy to read. It is quite easy to digest the data. So that's why this format is mainly used for the consumer part. So as a presentation, as some kind of data mart, or modelers quite like this approach, meaning that they have data prepared. They do not care how it's exactly what the start, what send. They have that one view which has information. Easy to read, but the problems are one that if you need to add new segment, for example, you need to add new column here, meaning that you need to redo, to think what you will do with history, what the historization there. Another point that each attribute, on this picture, you cannot simply say that what was happening there 10 years ago, or let's say 5 days ago, because it's one structure. And if you need to trace when some attribute, maybe you have changed your last name. How you find that from this object, you need to check some maybe logics, and then to compare one to another, so it's quite complicated. In the normalized structure, you quite easily can trace each attribute when that changed, when that happening. And for reporting, that's quite important, that you know when something has happened, because there is a lot of use cases when you need to show either something on specific date, or can you show when the changes are happening. Maybe there is something happening, why at that point of time, lots of people change their first names. Is there something happening at that place? Or maybe it is something else which brings in that information. So, and we have both, but I said it is depending on the use case, where it's located, what it is used for, it's created. But this first one is more to be as a central point of truth, so the data is stored once, so that you don't do it multiple times. The normalized form, most of the cases, and the data will be replicated to the several use cases based on the need. If we look for the data sourcing, as I mentioned, and manipulation there, so that one thing, this is extract the ETL, CLT tools that we're using. And what's important there with this tool set that we try to be as less painful to the sources as we can, meaning that we try to grab the data prepared from there in one go and do already transformations inside of the systems in the BI, be it warehouse or data lake, already do transformation there, meaning that they are much better to deal with that. And operational systems need to do their own stuff, and they are not really good to operate with huge amounts of data. Another point, it's calculation. So data warehouse should be able to do different data manipulations. Either it is running inside some kind of business logic to prepare some data, or it can also do the format that prepare data, feed into some calculation engine. Be it other tools, nowadays they are quite good connectable between different systems. If previously you should have some kind of standard output, now you can implement them, the easy connection points, how you can give data to one model, drag data back from new data, and call the execution there by automatic or schedule or something, get metadata as well. So new tool sets quite good, meaning that they are providing much more data and much more connectability between elements. So you can easily combine different models. One point here, this pre-calculation of the data. That's quite important part of our activities, and that is really helping a lot to deal with the data, prepare the data for consumers. One point it is that if, for example, you need to do report 1 year of some kind of payments, and you want to see that every month this report for this yearly payments. That's huge amount of data considering the number of transactions can be, I don't know, millions per day. Like, will you do that every time, do that? Or maybe you can do that every month. I will take all this month's transactions and do this pre-aggregation to simple numbers. Maybe with adding some specific dimensions. Maybe I want to add also channel, maybe a product, maybe something else. But generally pre-calculate this data. And then already when I need to do this 1 year, then I can take only, let's say, 12 metrics to combine, not this millions of records. And this we see how it actually really helped at some places. Some reports were running previously, I don't know, like 5 hours. With pre-calculated data, it can run 5-10 minutes. That's really possible. The negative side of that pre-calculated data, it's already not on the fly data, meaning that the timing issue should be considered. That it was true at the point of calculation. 2 days later, this has already might have been changed. So this should be taken into consideration. On the other hand, again, this, if you have, for example, calculated probability of the default, maybe it's not only your report who needs that information. Maybe it's some other reports, maybe it's tens, maybe it's hundreds. The more there are, the better it is, meaning that you're benefiting, that you have done it once and you will not execute. And for us, this performance still an issue, meaning that you have to pay, and that's quite expensive to pay for all the executions on the systems. Yes, they are powerful, but you have to pay for that. And I would say this is even more important than space. Now with cloud technologies, space becoming more cheaper, but manipulation with data, reading the data, it's quite costly, meaning that if you can do something once, some activities, then it is valuable not only from the speed, not from the time perspective, but also from the cost perspective. And also that, as I mentioned, so this metrics, data, whatever is calculated, it should be redistributed, so reused, as initially mentioned, make it once, use many, so that if you have done that once, do that, but it means that you need also to describe what you have calculated, what it is, what are the rule set, is it useful for everybody or not. Another point, it is scheduling, that the data has to be calculated when you need it or it's most useful. For the reports, again, like we have reporters, there's a normal people, they will come to work and start, I don't know, at 8 o'clock. But you can run this pre-calculate stuff in the early morning or maybe at night, meaning that they don't have to do that on this time. Also, you can do that when the data is ready, meaning that you most probably would like to run something, some reports pre-do that before, but as soon as the data is coming in. So you need to orchestrate this, and you can schedule, and that also helps you to understand when something will be ready, if something is late. So then you have possibility to adjust your activities and understand what it will be, what you should do further on with that. And coming to this data quality and lineage, that's very important. Already mentioned several times today that this is actually what helps to understand where the problem is, what we should expect. If there is an issue, what the reports will be affected. If we have not received from source some data, what it means, where it will be affected, what we should do with that. If you have issue, what reports we need to fix, what we need to recalculate. So that is always the case. It's always business do not want to deal with that, and that's we are always fighting that, yes, but you need that because it is one, second, third. And yes, that is the point that we need to deal with all the time, the data quality, data lineage, to understand, to trace the data. That's quite important for us. And if we're coming to the data provisioning, this last point there was how we provide data out. This should be fit for purpose. Generally, like the data, what comes in nowadays with these different GDPRs, whatever, you should take data which is needed for some purpose. You cannot just simply grab, let's give me everything. That is not working nowadays because you need to describe it, why you need that. There are different purposes, different legal approaches, what's allowed, what's not allowed, but that comes for data in, but it also comes for data out. If previously it was completely okay that give access to everything, why not? He is still bank worker, why he cannot do that? But then it comes in that you should see, you should use the data only what you you need for your activities and no more. There are different areas, different countries, different banks, maybe somebody buying in data, so there's limitation of the data. So that's quite important aspect for the data out, that security and access control is quite important and need to be handled. And this is handled on different levels, internally in the warehouse, as a part of reporting tools, other tools that everybody should follow that, but it's also quite a topic for us. And as for the users, we have different type of usage. So non-IT users, meaning that we have different business users who come and they say, I don't understand, give me a nice picture. Okay, in best case Excel, but give me a picture, give me this round chart, something else. And then yes, there are teams who are doing that, preparing this report. They are scheduled, maybe one time, they're running some time, and they receive that as a result. Another point that there are this non-IT but advanced users, meaning that they have access in different reporting tools here so that they can combine themselves, but based on the business logic. They don't understand some SQLs, they don't understand databases. They just know, okay, I have party, I have contract start date, end date, and some kind of, let's say, I don't know, income. Grab that in, tools are smart enough to create you some kind of charts, dates, how it was changing, some trends, some information. So this is also possible to solve with BI, with different reporting tool sets. So they're quite good at this nowadays. Then we're coming to this report is modelers. Those are, to some extent, preparing those first reports that there are on top. But on the other hand, they are different models who want to either try out new models or create new models or do something else. Then they can get, as an input from the warehouse, different prepared data sets. Either it is views or it is data mart, is it data sets, some files. So this is also an provided information for the consumers. And there are advanced users. So this is, say, the users that have access to the most information, of course, if they're allowed to do that, to do different ad hoc reports, mean that they need to understand the logic. They need to understand the model of the warehouse to understand how they should grab the data and how it's correctly done. Because if previous ones do not care, because they just need the data. The last ones, if they're allowed to do, that means also bring the problem that you need to do that good way. You cannot do that, it brings performance issues, that it brings some kind of data inconsistency or something else. So that's always the case, that more freedom, more responsibility together comes in. And from the tool set, so one I said, there's different reporting tools. They are part of BI, so how the data can be presented. There are different existing, some business object, click, sense, some MicroStrategy, whatever. There are different tool sets available in the market, and our approach that we don't limit it to one. There are different use cases for different toolsets that can be used. I will go to the batch access and prepare data set. That is the most common data share for the data warehouses, meaning that either it is monthly batches or is it daily batches, which is provided to different systems, either calculation systems, operational systems. You just prepare, and every month or every day you provide that information out to do whatever activities which is needed in that tool. They are just the difference between them. Is it pull or push? So that is it batch access, meaning that you create layer, you create logic how it is best done, but the consumer will take when he needs that, or it is prepared data set. Then you prepare, you create file and send it to the tool which needs the data. Then they don't care about your performance, and you can do that when it's most fit for yourself. And there is also one option, it is operational access. You are coming to the branch, you want to take loan, and then either person can send you home, say, okay, I'll check with a day or two what we can do with that. Or they can go and check from the database information about yourself. The warehouse is a place where you get, I don't know, what's your status, what's your credits, what's something else. So they can do that, but it is tactical, meaning that quite often it's considered that it should be 2-3 seconds maximum. So you should do that fast without impact on the performance, but you have high availability there. But this is also an option. Otherwise, you just grab those daily information to that system. But considering that you have maybe, I don't know, millions of customers and you need daily that information only for 200, maybe you don't need to grab and drag all that information to that space. Maybe at the point when everything is located in one place, maybe it is not that an issue. But nowadays, you need to move this data from one place to another, and then it is costly, timely, and is it really needed? So that's also the case that we are solving to do. Provide data. Yes, that's the end from my side.
Thank you very much, both to Koit and to to Jürgen and to Artem. It was very insightful. I'm sure we will have lots of questions. Now, maybe first, if there are questions directly about this presentation, otherwise we'll move to the panel. Yes, please.
Thank you for the interesting presentations. I want to ask about data kind of integrity or immutability. So I understand that you probably have some kind of data that has to be immutable, like transactions. You shouldn't change them afterwards. How do you achieve that? Do you use some kind of distributed ledger technologies, blockchain technologies, or do you? And if you use those, do this affect kind of performance, or do you allow changing some kind of critical data in some scenarios afterwards, after, let's say, some kind of transaction has happened?
Mm-hmm. So yes, data immutable. There are different levels of this immutability, meaning that the data lake and what we are going nowadays, it's not for everything, but the data comes in and then it is true to source, meaning that what source provided is there. So, and if it's, again, that's the question, is it needed? It's not always needed that data should be immutable everywhere, but if it's needed, it can be stored there true to source. If the sources are providing files, for example, as an input, then again, they are also stored, they're immutable. Direct database connection, this is again, warehouse is also, let's say, trying to be true to source, meaning that it takes data, it stores as its source. You will not do the changes to the data in the warehouse. If the change is happening in the source, that might be considered like, should it be done or not? Should it be propagated? Because it should be true to source. But again, that data which is coming from the sources is considered to be immutable, meaning that we are not changing that, we are not adding. So all the value added information, then it's you should see that you can trace that and you see where it's available, but you see that it is different. It is not coming from the source. That information is not deleted and not removed. It is still there. So it can be value added on top. It can be derived what is happening, so that if for some reason sources are not possible to add some kind of relation or something else, then it can be derived, but still it will be added, but not removed to that. But in case of the warehouse, it's already modeled data, meaning that there was still some kind of changes in the data. It will not be the full source there, because some maybe attributes were not taken, something was technical, but information that came in, it's considered to be immutable.
Any other questions about the last two talks, please?
Yeah, hello. Can you maybe share some insights about specific technologies you are using? Like what's the technology for data lake and what's the warehouse technologies and what's on premises, what's on in the cloud and such things?
So let's say for the data warehouse, it is Teradata we are using. We have several systems. We also have some legacy ones which are using some, I don't even remember, what was it? Is it DB2 or something? So older systems as well. So there are different ones there. For the data lake, I don't know what it is actually. They're changing it nowadays. I'm not sure actually. Do you know, Jürgen? So I know that.
Azure cloud, but you have to say it because I'm not mic'd up.
Yes. So that I think it's Hadoop Azure cloud there, and what's data lake? I think it's Hadoop was, but I'm not sure really what's new technologies there. They say I'm getting that to myself nowadays. I'll have to take that in this data lake stuff more, and to find out what they have finally implemented.
Thanks for the good presentation, though. My question was like, for how many months or like there is some time period for which the data is stored and like which can be retaken and like processed and like refined to get some value out of it and like to prepare a metadata out of it. So how much does Swedbank keep it? Because where I was working in the company, they were like we used to take out the data only for the 90 days, and after that it used to go to Glacier and it used to be stored because it was a cloud Glacier. We didn't use data warehouse there. So what are the perspectives of data warehouse or data lake for like how long it can be extended to keep the old data and to pull it and can be refined? Like anytime it has happened with Swedbank, like the oldest data has been pulled out and like taken out and did a metadata out of it and refined or something like that?
We are not deleting data right now. We're in a process to have this as the new regulations coming that some data should have some kind of information. But the case, then it is exactly right now we are looking for the process how we connect the data to the consumers where they need. So what is the longest? But I would say that a lot of the consumers need the data from the beginning of the bank establishment, meaning that it is for 20 years data and it will continue. So I'd say we are not deleting data from there right now, except if it is really right now some kind of legal stuff that should not be there. But that's already a new approach, new stuff which is needed. But otherwise, you can do whatever, and just some data is coming to, let's say, this cold storage. But again, it is still available on the warehouse, just different location, different place, but it is still there and you can easily connect to it. For operational, I don't know, it's like several years, but depends what is needed, what kind of reporting there. But still, data is all in the warehouse.
Thank you.
And that's a good question. I might want to add to that it's kind of our predicament a lot of the times that we don't have all of the group level sources in our warehouse, right? We started from building a Baltic warehouse and now we're expanding it. So there are other legacy systems as well. And for example, we bring a Swedish source in, or Danish, or even New York, and we see that the operational system has 3 years of data. But our customers are credit risk modelers, and they say that if I don't have 20 years, then I can't do anything with this information. So that's a problem that we always need to solve. But then again, as Igor mentioned, the regulations fit for purpose use, that we might have some events, some balance and some transactions that are needed for modeling for a long time, but then for some cases we cannot have them anymore tied to a person. It needs to be pseudonymized, for example, and so on. So you've kind of opened a Pandora's box here a little bit. So we have it for a very long time, but that doesn't mean that we have every single thing for a very long time. Or we can have that, currently we actually are investigated today one table where we have 19 terabytes of data in one table. And we started looking at it that people still use data from 93, but they aggregate on top of that. So if you aggregate it, make it available, maybe that can go to the sub-zero cold storage, let's call it, right? That we don't need to keep it active. So that's like a constant thing to evolve, that we need to keep this system alive. So excellent question.
Other questions? Otherwise, we're gonna use these chairs in the other direction now and invite everyone to join in a discussion. First, you can jump in anytime, yeah? Otherwise, I will make some highly provocative statements that will make people jump out of their chairs. That's why there are chairs, and that's why the chairs are tall, so that jumping is simpler. Yeah? And then comment on those aspects, right? Yeah. So first, related to the first presentation, right? We see a little bit of an evolution or a trend, right? That went from data as a pet, yeah. So you caress it, you grow it, you water it in the morning, you make sure it's good, and that the data is in very good condition. You make aggregates of it and so on. And that's the data warehouse philosophy, right? And now we move little by little with this philosophy of data as cattle. There's a lot of it, lots of data. We can get more data out there. We can get data sets from different places. So we just dump these data sets into this data lake. And then we say, when you need something, we'll build a pipeline to get the aggregates you want, with the cleaning you want, et cetera, with reusable models in Spark and stuff like that will do all this work for every analysis you want to do. So you have a bunch of cattle, and when you need something, you take them out and you clean them up and you give them to the user, right? So is this a trend? So are we gonna see more, in your opinion, data as cattle? Or is this just one of these hypes that makes you swing in one direction? So data is a pet, now data is a cattle, and then at some point in time people will realize we cannot be like doing this processing and like doing all this pre-processing for every pipeline out there. Every time we want to build a new model, every time we want to do a new analysis, we're going to build a new pipeline, and we're going to keep cleaning things 10,000 times in the same way. So go back to data as a pet, and we're going to start again going back to more of a data warehousing philosophy. So I want to get your viewpoints, from very different perspectives in what you think about it. Anastasija, since your presentation was first, please go.
Yeah. Thanks a lot. Indeed, a very nice question, and it is worthwhile to discuss among different people because we have different perspectives. Because from my perspective, I would say that my general view on how people see this and my personal view differs a bit. So as I referred a bit to the study we conducted together with my colleagues, although we decided to go to data lakehouse to take those advantages, but nevertheless we tried to have some more aspects of data warehouses, because we respect data and we want to have this data as structured as possible. So to get those advantages, data lakehouses proposes, but at the very same time dealing in an old-fashioned manner. What I see currently but of course it is not generalizable, but rather what I saw, it seems that indeed, considering the huge amount of data, maybe we will not have, at least at the very beginning, an opportunity to behave other than dealing with data lakehouses, where in some cases indeed it is not so very from the perspective of person dealing with data management, and in a very traditional sense, maybe it is not so very respectful to the data. So to deal it, just to put it together, and it is your own problem and headache, business person or someone else, how to deal with it, how to ensure that you will really derive the right insights from this data. And if those insights are not correct, this is your problem because the data was more or less okay. And although it is considered that the data lake and data lakehouse is a sort of how to ensure a single source of the truth, nevertheless, with time, from my perspective, it will be also understood that dealing with the data in such a way, just putting everything together and then relying on the person how it will deal with this data later on, if the very accurate and very well maintained and very well developed data governance and probably somehow very hard-coded is not implemented, most probably it will appear that the data lakehouse is not a single source of a truth, because in some cases, what I see right now, actually data warehouses tend to be, if again a list of prerequisites is fulfilled, is met, tend to be even closer to a single source of a truth. So yeah, but again, different perspectives from a single person, but most probably we'll have more perspectives.
Anybody wants to add anything?
Maybe I can comment. I don't know which one should I use. I also have this one on, so maybe it works. Yes, good. So like to kind of go forward to a place where we have all the underlying data easily and quickly available, and also, let's call it near real time is the hype word that everybody is so happy about. It's a target for us as well, but if we look at on an enterprise level, so I'm veering a little bit from the question, but it ties into it. If we look at on an enterprise level, then we have not only different areas of an enterprise for big companies, but actually like sister companies within one company. And then we reach to a point that you actually mentioned, governance. And if everyone gets to bring your own data in some extent, but there is no governance, then it becomes noise. It's not data, it's noise. And that's kind of our worry, that we're a little bit backward thinking that the warehouse is here to stay for a while, because this governance allows us to kind of take ownership in it by ourselves, and also have who give us this data to kind of through us take this ownership. Otherwise, we've seen instances like in other big companies, in some cases in ours as well, that once the data steps out the door, it's not my problem. So, but it is your data you're providing to the enterprise. And I see that even with the cattle approach, that's going to be really problematic. With the pet, at least, they can feel some resemblance of ownership to their pet. Of course, some people throw their pets out the door as well, but most of them don't. So I see that solves an integral problem where an enterprise isn't ready to really embrace to be data-driven. But we are moving in this direction and quite rapidly. But I see that that's a big obstacle in kind of seeing as it a pet or a cattle. It's also like the maturity of the organization, not just the technical capability to do it. So I got this little sidestep, but it's a topic close to my heart, so I wanted to get it out.
Anybody wants to add?
I can add one thing, that actually we have different situations, and when you say how it should come in, it's quite dependent on what kind of source it is. Can they do that or not? Meaning that if it is source which we cannot control, we have problem with that, or they are not doing that, it's some kind of provider of data, it is costly, they don't understand something else, then it's easier. Bring data in, we will do that, they don't do that. On the other hand, if you have sources which is still part of your enterprise, they understand their data the most. They understand what should be done, and they share the data maybe somewhere else. If you fix it in one place, it will not fix in the source, it will not fix further on. For some reason, you need to take it, you need to send it somewhere else. So I mean that it is best if it is fixed on the source. That's what we try to do. What we try also to do, that we try to make the sources to be presented on data lake or warehouse, meaning that they are responsible understanding the data, how they also provide, not only how they do it internally, but this is also part of the activity, how they will provide. So it is quite dependent on what is the source of that. But I agree. So in some situations, it's quite easy to take in it. Let's deal us with that, because it's much more problematic to wait it always there. In some situations, it's better to have this already done in the sources. And if there are some changes in the source, again, you have fixed one thing, they have fixed another, you have, again, broken it. So to some extent, of course, but not everything. I don't see that we can do it easily, that shift in everything and we will solve it somewhere else.
Any comments, questions from the audience? Yeah, not enough, not enough. So I need to be more provocative, to provoke some reactions. I need to make people jump out of the chair. That was not enough. Okay, so the economy has its cycles, right? And I think we all know where we are in that cycle right now. Yeah, and it's not going that way. So and we know that when there is monetary squeeze and there is like less appetite for risk and investment and so on, and long-term thinking and long-term investment, well, at some point in time, every single expense in an organization is going to be questioned. Do we really need it, right? So somebody debarks at some social media company and says, do we need all these engineers? Get rid of them, right? Okay, now the past cycle we have had, it's like there's something that I don't see an equivalent in the previous ones, is the generation of people with explicit data titles on them. Yeah, data scientists, boost, then which led to a boost of data engineers, because I saw that every data engineer needs to sit on top of every data scientist needs a data engineer to sit on top of that, and that data has to come from a data warehouse, so another BI expert comes on board. So it doesn't seem to me, and I have been in cycles since the late 90s, that there was a previous cycle where there was so much growth in the exploitation of data as there has been in the 2010 to 2021 cycle, yeah, of growth. So, and we created a Masters of Data Science, and there are more data scientists coming out of our masters, etc., etc. Could it be that organizations are going to struggle to justify the size of the investments they currently have in their data assets, let's call them, and that is going to require new ways of thinking in terms of like justifying things like data cleansing, yeah, justifying things like improving your ETL pipelines, justifying things like improving, adding controls into your data governance, right? Because that's the place where we say, hey, that's not delivering value. That's not telling me which customers I should target to avoid more churn from my bank into some fintech or whatever, right? So, any thoughts on that matter from any of you? Of course, the business people now have more to say, perhaps, but let's start, Mohamad. Go.
I don't know. I'm not really in the business intelligence, but as you said, usually when you have growth, a lot of money, so many companies will be investing. It will be easier to get a job in this new trend, let's say. But when you have limited resources, you start to squeeze what you have. How beneficiary was our research here? Do we need all these people? So it's not because I'm not in the area, but I think this will be one of the areas will suffer the most. Because you, first of all of you will be in the business market soon. You should keep in mind one thing. No matter how good you are always replaceable. So the thing is not about you are replaceable or not, how much you will cost. And this area, with respect to everybody, it's not really hard to have a job in it before, but it will be very hard to have a job in it in the future. And they will prefer somebody with experience, so they will try to keep as much as they can from the previous one. I might be wrong, I don't know, but we will see.
Well, That's great. That's the pessimistic scenario. Let's hear the more optimistic scenarios.
So maybe I can give it a shot. So I'm going to stay with the pessimistic scenario, and I have to squeeze one kind of promotion item into this. So if in the future they will be looking for people with experience, now is the time to get that experience and get into the field and be valuable when the squeeze comes. But all that aside, from our perspective, we have to be realistic. I could sell BI forever and say that it's such a vital part of business. Never, we will be downscaled. Let's be realistic. Anything can happen within a company depending on how the company is doing. Companies even close. Then everybody is laid off. So from that perspective, we need to understand what value actually we add, and kind of maybe through some of the examples, not just getting these new products out, but as I mentioned, the IRB scoring. The bank had it before, but now credit risk management is becoming tougher and tougher by regulations. So Igor said previously that everything can be done by humans if you have enough humans. But in some cases, we are reaching a point where it can't be done by humans anymore. Like humans can develop a solution, but it needs to be like, it can't be that the business people can just, whip up their Excels and work on it, because we are in a situation where we need to know the probability of default of a customer the next day, and the next day across the group, across all of the products that they have. So no human will be possible to kind of extract that data, make it available, and from that perspective, I see that when a recession hits, we won't grow exponentially. However, BI in at least large institutions cannot go away, because the other way, then other areas need to grow too much, or otherwise sacrifice compliance or something worse. Or actually, compliance is pretty much the worst thing you can sacrifice. So from that perspective, we'll be there. But of course, the question is in what size, and then kind of in how many new initiatives and how many new cool toys we get to buy. Do we get all the cloud solutions, or do we have to make do on an on-prem solution for a few more years? So that's probably going to be the limiting factor, but not that. So I agree that it might be difficult to kind of come in as a completely new person, but the market niche remains, and it will remain quite strong.
Yes. In other words, like in a way, actually, sometimes to reduce cost, to become more efficient, you actually need to look harder into your data, to see where can you make those reductions and so on. So that's, it can also be an opportunity. So for data science and business intelligence. Any questions until now? No? Yes, please.
Thank you. So looking at today, not looking into the future, how would you describe the market for workforce? Is it like on the side that there is a lack of skilled workforce, or is there like an equilibrium, or are there more jobs than people? How would you describe the state today?
Okay.
That's a tough question. I leave it to you guys.
Probably to this corner, right? So I'm going to have to break it down into some of the parts, right? So if we look at general IT, then people are hiring everywhere. If we're looking at GBI, we're growing. We have growth. What do you remember? I don't know. We were like reaching 600 in December. Right now we are reaching 700 this December. Of course, this is not going to continue. We need to level out at some point, but it will depend on the job, on the role, so to speak. That in warehousing, usually the engineer role is quite different from a person who deals with React and Node and whatever, and kind of gets to play with all the cool toys and do the Git projects. It's a little bit of a different world. So the situation where we're at is we want to grow, but sometimes the pool is quite dry. And so we are also kind of having consultancy overseas. And of course, we are on group level. So we don't only stick to Estonia. We have people from Estonia, Latvia, Lithuania, from Sweden, and people coming to live in Sweden, and also in some cases in some other like semi-home markets, you know, in Denmark, for example. So we see that we have options. We would like to get more experienced people, but sometimes it's such a niche skill that we're after. So if someone comes and says, I'm a senior developer, I've done C# for 10 years and I can do everything with Microsoft tools, and we're like, okay, your thinking mindset will help us, and if you work with relational databases, but you might be a junior warehouse engineer. So it's kind of like, that's the problem we're facing. I don't know if I'm directly answering your question, so I'd say that there's still room to grow, but we target very specific competencies in some cases, but not like the bank in general. We have several products everywhere, right? So, but I'm not going to do a sales speech anymore. So let's continue with BI specifics. But
I would say that actually, anyway, we are coming to this real-time data, meaning that we need to do this automatically, meaning that it is not anymore possible to put a person there to do that, meaning that anyway, the modelers, it is something that comes in one and other areas. It's now becoming more and more popular that we have now business people who actually take people with modeling knowledge. So if previously they take that, we need person with business logic, or say business process understanding. Now it's, and modeling, please. Meaning that it is growing outside, and with real data, real-time data, with this, it's not only this reporting, but you also should be able to fast react on the market, fast react somewhere else. So for sure, it can hit that, not do that fancy, maybe not that often, but anyway, this is something that still continue to grow, and I would say from what I see, it still continues, that still need will be, at least for some time, at least something new is developed. I don't know, maybe at least some computer will do that for us, then maybe it's a different story.
Yeah, and 10 years ago, I believe half of the developers heard that, you know, coding in the future will be done by computers. Maybe it will, but the future is not here yet, so similar with this. So.
Yeah, so no, you don't see a big shrink in the demand for people, but probably a reshuffling. You know, some areas will actually benefit, you know, from reconversions, and some other areas might be affected. You know, of course, the more you are commodity, the more you will be affected. The more you have special skills, the less you will. Please go ahead.
So I wanted to ask this question from first, like when we were talking about information security, guys, and like, because I have been working as a cybersecurity analyst for 2 years now, and I had this question for the data engineers and everyone. Like, this bank is always a target for like every kind of security vulnerabilities and attacks. So it was always difficult for us as well to handle the banking clients, which I was handling as well. So there was like, we used to like tell them about some security standards and to follow them, and they used to be like, they had a huge data, and to protect them, they need to like gear up their own data standards and like increase the security, but they were not able to do that and had some of the attacks and something like that, like many times. So how hard it is now, like for you guys, it is getting harder to handle these kind of security guys and like to deal with them, like whenever they say every year or every month that increase your security postures for this, because always the data increases, there's like risk of getting more vulnerabilities as well, like day by day. So how is it like increasing, and how are you guys able to handle this? Because I had never gotten like this opportunity to ask this question to anyone, because like no one directly answers these like about data things, and so I wanted to ask this question.
Okay, so Igor can correct me where I'm wrong here in a lot of things, but I also see a different picture a little bit away from the warehouse, that I can't give out any bank secrets, but let's be honest, we are a big corporation. There's a lot of legacy everywhere, and it's a constant. I think it's twice a week kind of where I am as a manager, I'm in, not like from externals, but from internal kind of reviews, like where do we have something, black applications, red applications, what do we do, what are the mitigating actions, and those things also land into our investment plans, let's call it, like, you know, the Excel terms of management. So we don't have just the new shiny features, but we need to have it because we are a bank, we cannot allow that, if we find something, then something goes wrong. So, someone found an error in Apache 12.4 or something in the beginning of the year, poof, 12 weeks of our development, not 12, 2 weeks of our development time gone, just focusing on this, that our systems don't have an impact, right? That if we do, how do we move away from it, or how do we mitigate it? So that's actually maybe, because we're so big, there might be a lot of not incidents, but potential incidents. But from another angle, because we are a bank, we are slower than other companies, when they think, oh my God, I came here as a developer, they had all those cool tools, you have none. It's like we have to kind of use everything that's like triple checked, and if there's a vulnerability, to deal with it. So from that perspective, I think we are actually in a pretty decent state. Nowhere near perfect, of course. But another problem, maybe the politicians' answer driving the question away. Another problem for us is actually regulations not on physical vulnerabilities, but the data itself and the data availability and access, as Igor also mentioned, to how this access is granted. And that's actually the major pain in the wherever, that how to kind of make it in a way that if we have all this data but we can't share it, then what's our value? So we have to find a way to share it in a way that we don't infringe on anyone's personal rights and all of the use is justified. So that's actually going to be the real problem to solve, but not the physical vulnerability is still there. And a nice example from recent past in Estonia, so if some of you couldn't access some of our systems a few weeks ago, can't give you full details, but basically it was actually a remedying action for a security vulnerability in our infrastructure, not GBI, but bank level. And so the new kind of rule thought that internal traffic is malicious and just cut it off. And then some of the systems didn't work. So we were too secure, so secure that we couldn't do business. So there's always a balance, but yeah, it's a constant thing for us. And of course, details you will never get out of me or from him. So then you need to be an auditor to come and ask those things.
Thank you.
Right. So security is a marathon for sure. So I think we have a little bit come to the end of the time that was allotted, and there might be some drinks or something there. So I'm sitting between you and them. So what I would like to do now is to thank a lot all of the speakers. Thank you very much for giving your energy, your time, and thank you for coming as well. And we will be having these data science seminars, I think, roughly once per month between now and May. Take advantage of it and go and tell the people you know that it's great. Come here and there are drinks and we can network. We hope to be seeing more people coming post-Corona because we had a lot of people during Corona via Zoom, but we are now trying to force people to come, and it's a little bit hard to get people out of their pajamas. But spread the word. Great event, and let's try to get more people next time. Thank you very much, and thank you.
Thank you. Thank you.
Thank you.
It's amazing how people will just wait for the video.